When trying to develop a self-driving vehicle, one of those common roadblocks in the race to self-driving is accurately replicating human intuition. When you see a road like this, with clear lane markings on a bright sunny day, it's easy to think that you can just hand-code a model to drive your car, right? Just stay centered between the lane lines and don't hit anything. But when you take this approach, you'll quickly start to realize how much of a mind game driving actually is. What happens when the lane lines are faded or mismatched? What about when there are just no lane lines at all? As humans, we know how to take in information from our surroundings and make an educated guess as to what the correct course of action is. This is why Comma developed their Laneless model. Trained end-to-end, the Laneless model drives not on hard-coded rules, but by attempting to copy what it has seen humans do by looking at driving data from Openpilot users. In this video, we will be going over 3 scenarios that might prove tricky for a hand-coded system and see how Openpilot's Laneless mode handles them. First up, we have a scenario fitting for Laneless mode's name: a country road with no lane lines. As humans, it's easy for us to distinguish the edge of the road from the grass. Where systems by traditional automakers that rely on trying to find a solid set of lane lines may struggle, Openpilot is able to continue driving on the road just fine. Humans also know to stick to one side of the road to make way for oncoming vehicles, and since Openpilot is trained on human driving data, it also accomplishes this task. Openpilot is even able to continue this behavior on laneless roads with more curves. Second, we have an intersection. This is one of the most common scenarios that Laneless encounters, often having little to no lane markings telling the system how to get from one side of the intersection to the other. But regardless, Openpilot continues on through the intersection, spotting the continuing road in the distance and following through. Lastly, we have a bit of a 2-in-1 clip. First, Openpilot encounters a curved intersection. It enters the intersection, turning slightly to the left to enter the upcoming lane, when it quickly encounters our next problem. Here we can see old outdated lane markings, which could easily be mistaken for proper lane lines by a system hand-coded to follow them. Thankfully, Openpilot's Laneless mode drives over the false lane line, continuing to drive properly by taking in context clues from its surroundings, as well as human driving data that had previously been trained on. After looking at these scenarios, I hope I was able to convey the importance of end-to-end learning when it comes to self-driving technology. While there are certainly impressive hand-coded systems out there today, in the long term, I believe an end-to-end system such as Openpilot's Laneless mode is ultimately the better path to take when it comes to a task that requires as much intuition and nuance as self-driving.